Hello guys, this is Aarya Labhsetwar from Division K and this is our COA course project and our topic is Hardwired Control Unit and I am going to talk about introduction and its block diagram. Firstly, I'll talk about introduction. It is one that contains control units that are used fixed logic circuits to interpret instructions and generate control signals from them. In a hardwired control unit, the control unit produces output control signals as a function of its input signal. It is shown in figure. Hardwired control is typically used for implementation unit in pure RISC. This is a block diagram of hardwired control unit. First, this is a control step counter which keeps the track of the time of the operation. This is instruction registers, which passes instruction to fixed logic circuit. This is also called as control unit. This is external inputs. This takes care of the execution part. This is the conditional codes, which passes the codes to CU, which is passed in form of control signal.
My name is Anushree Laddha, roll number 34. I am going to explain structure and design of hardwired control unit. It has an instruction register and a sequential logic circuit. Sequential logic circuit has many AND gates, OR gates, ICs. It gets input called as status signals. It tells about the status of instruction. Clock is also one input and output is control signals to the instructions and then they control them. It uses fixed logic. IR is used to know about which instruction is going on process, what is its status, and which control signals need to be generated for it. It interprets the instruction and then generates the corresponding signals. Now, factors for design. First is amount of hardware. You have to keep in mind that making a sequential logic circuit does not need much hardware. Second is speed of operation. If we increase the speed, that is we give it efficiency. So this also can be a design factor. Third is cost. Cost is nothing but computation resources that we have used. Now there are 4 techniques for design of hardwired control unit. First is state table method. It is a sequential design which has less hardware. It changes its state according to the instruction and then generate control signals. Basically, we can implement it from FSM. Every generation of states has a set of control signals. This can be a disadvantage as it might cause synchronization issues. Second is delay element method. In this method, control signals get generated in a proper sequence. There is a specific time gap between two signals. It helps in proper synchronization. Third is sequence counter method. It uses counter for timing purposes between two control signals. Fourth is PLA method. So it uses programmable logic array. In this, we have an array which has logic of every instruction set. We can update that logic by programming, so it is called as programmable logic array.
This is Aditya Lad. I am going to tell you about the hardwired implementations. So its first implementation is in control unit inputs and in flags and control bus. It also finds its use case in instruction register, like for unique logic for each operations code. Decoder takes encoded input and produces single output, n binary inputs and 2n binary output. This is all possible with the implementation of the hardwire. And it has also its use case in clock for repetitive sequence of pulses, useful for measuring duration of micro operations, must be long enough to allow signal propagation, and need a counter with different control signals for T1, T2, etc. Again, this is all because of the hardwired implementations.
Hello everybody, this is Mayur. I am going to explain topic of hardwire control unit. The cycles fetch, indirect, execute, interpret are constructed as a state machines. So fetch, indirect, execute, interpret are constructed as a state machine in cycles. The individual instructions executions can be constructed as a state machines. Common sections can be shared. There is a lot of similarity one ALU is implemented, all instructions share it.
Hello everybody, I am Gokul Kurandale from Division K. My roll number is 30. I am going to explain the topic state diagram. It shows states and action that cause transition between states.
Hey guys, I'm Pallavi Kurkute. Let's see about problems with hardwired design. Complex sequencing and micro operation logic, difficult to design and test, inflexible design, difficult to add a new instruction. Then we'll see disadvantages and advantages. Complex sequencing and micro operation logic, difficult to design and test, inflexible design, difficult to add a new instruction. Then advantages is faster.